In this video, I'll explain application of matrices and determinants. First, let us see what is meant by adjoint of a matrix. Adjoint of a matrix A, where A is a square matrix of order n, is denoted by ADJ of A, adjoint of A. It is the transpose of cofactor matrix of A. Therefore, first you have to find out cofactor matrix of A, then take the transpose of that cofactor matrix to get the adjoint of the given matrix. For example, find adjoint of A where A equal to, this is the given matrix. Now to find the adjoint, first we have to find out cofactor matrix of A. So I will write it directly, I will find it directly. So cofactor matrix is nothing but minors, by deleting minor of Aij is the determinant obtained by deleting ith row and jth column. Cofactor means it is the minor along with the sign. So the simple method to calculate cofactor matrix is, so first you have to delete first row, first column. Then you will get this determinant 5, 0, minus 2, 1. Okay, next, this is the first element of cofactor matrix of A. Then delete first row, second column. So you will get minus 4, 0, minus 1, 1. Then delete first row, third column. You will get minus 4, 5, minus 1, minus 2. You can find out individually also, but I am doing it directly. Now delete second row, first column. Then you will get 2, 3, minus 2, 1. 2, 3, minus 2, 1. Now delete second row, second column. 1, 3, minus 1, 1. 1, 3, minus 1, 1. Then delete second row, third column. 1, 2, minus 1, minus 2. 1, 2, minus 1, minus 2. Now next, delete third row, first column. 2, 3, 5, 0. 2, 3, 5, 0. Delete third row, second column. 1, 3, minus 4, 0. 1, 3, minus 4, 0. Then delete third row, third column. 1, 2, minus 4, 5. Minus 4, 5. These are all minors of each element of the given matrix A. Now to get the cofactors, these minors have to be multiplied by sign. So sign is put in this way: plus, minus, plus, then minus, plus, minus, plus, minus, plus, alternative plus minus. Now you have to evaluate this to get the cofactor matrix. So cofactor matrix of A, which is equal to, now 5 and 5 minus 2 into 0, that is 0. So it is 5. First element is 5. Next, minus 4 minus 0 it is anyway. So minus 4 into minus 1, so it is minus of minus plus 4. Here 4 2s 8, minus of minus plus 8 plus 5, it is 13 with a plus. Here it is 2 1s 2, minus of minus plus 3 2s 6, 6 plus 2 8 with a minus sign, therefore minus 8. Now 1 1s 1, minus of minus 3, that is 1 plus 3 4 with a positive sign here. Next, minus 2, minus of minus plus 2, minus 2 plus 2, 0, 0 into any sign, it is 0. Now last here, 0 minus 15, so it is minus 15. Then 1 into 0, 0, minus of minus plus 4 3 is 12 with a minus sign outside here, minus 12. Then 5 1s 5, plus 4 2s 8, 8 plus 5, 13, and the sign is positive. So this is the cofactor matrix of the given matrix A. Now adjoint of A is equal to the transpose of cofactor matrix. 5 4 13, minus 8 4 0, then minus 15, minus 12, and 13, writing rows column wise. So this gives the adjoint of the given matrix. You can find out the cofactors individually also, that is A11 is equal to minus 1 to the power 1 plus 1 into M11. So here minus 1 to the power 2 into m11 is this value 5, that gives you 5. Then you are writing the cofactor matrix, then taking the transpose. But this reduces your time. You are finding the cofactor matrix of a given matrix directly, then taking the transpose to get adjoint. Therefore, adjoint of a matrix A is the transpose of cofactor matrix of A. Cofactor matrix is obtained by finding the minus, then applying the signs, alternative plus and minus, starting with plus. Now when you have a 2 by 2 matrix, there is a shortcut method to find the adjoint of the given matrix, that is given by adjoint of A equal to interchange these diagonal elements, that they are 2 and 5. So interchange them 5 and 2. Then change the sign of the remaining elements, that is minus 1 and it is minus of minus plus 1. So this is how we get the adjoint of the matrix. The usual method is a11 equal to minus 1 to the power 1 plus 1 into m11, then a12, then finding a21, a22, then writing the cofactor matrix, then taking the transpose to get the adjoint. But when you have a 2 by 2 matrix, interchange the diagonal elements, then change the sign of remaining elements. If it is positive, make it negative. Negative means positive. This is how we calculate adjoint using a shortcut method. Next is inverse of a matrix. If you have a square matrix A of order n, then this matrix A is invertible if you can find another square matrix B which is of same order n, such that AB equal to BA equal to, you will get identity matrix of order n. So then we say that the given matrix A is invertible. So if A is invertible, to find the inverse, we make use of this formula. A inverse is adjoint of A divided by determinant of A. Therefore, A inverse exists only if determinant of A is not equal to 0. So, because it is in the denominator. And some of the properties of invertible matrices that A inverse whole inverse gives you AB whole inverse is B inverse into A inverse. This is called as a reversal law of inverses. So, invertible matrix means you can find another matrix B of same order such that the product AB or BA is always equal to the identity matrix. Now, let us solve one problem. Verify AB whole inverse is equal to B inverse A inverse for these two matrices. First, let us find out AB. Okay. That is multiplication. This 2 by 2 matrix, it is also 2 by 2 matrix. Number of columns equal to number of rows of second matrix. Hence, the product is defined. How to do that? 2 1s are 2 plus 5 3s are 15. 2 plus 15 is 17. Then 2 4s are 8 minus 6 here is 2. Then minus 1 plus 5 4s are 20, 19. Then minus 4 minus 8, so which is a minus 12. So this is a AB. Now I want AB whole inverse is equal to adjoint of the matrix AB by determinant of AB. Now to find determinant of AB, cross multiply this. 17 minus 12 minus 19, that gives you minus 204 minus 38 minus 242. Now we want adjoint of AB. How to find adjoint? Interchange these diagonal elements, then change the sign of these elements. So minus 12 comes here, 17, then minus 2 minus 19. So AB whole inverse is determinant AB, then 1 by determinant of AB to adjoint of AB. Keep it as it is. This is equation 1. Now we have to prove the right hand side as B inverse into A inverse. Let us find out B inverse. This is B. B inverse is adjoint of B by determinant of B. So determinant of B is minus 2 minus 20. So minus 22. Adjoint is interchange these two, minus 2 1. Then change the sign of 5 and 4. Minus 4 minus 5. So this is B inverse. Now to get A inverse, adjoint of A divided by determinant of A, which gives you determinant of A is 4 to the 8 plus 3 11. Then adjoint of A is interchange these two elements 4 and 2. Then change the sign minus 3 and 1. Now multiply these two matrices B inverse to A inverse. that gives you minus 1 by 22 into 1 by 11, so which gives you 1 by minus 242. Then multiply these values here. 4 2s minus 8 minus 4 minus 12, then plus 6 minus 8 minus 2, then minus 20 plus 1 minus 19, 15 plus 2 17. Now compare B inverse into A inverse is same as AB whole inverse, hence AB whole inverse equal to B inverse to A inverse. We have verified this using the reversal law for inverse. Now if you have a 3 by 3 matrix as we have done in the previous case, now if you want to get the inverse of this matrix, so A inverse is equal to adjoint of A divided by determinant of A. Adjoint of A we already found. Now we have to get the determinant of A value. Determinant of A equal to, this is plus minus plus, so 1 into 5 minus anyway 0 minus 2 into, delete first row second column, minus 4 plus 3 into, this gives you, delete first row third column, so we will get 8 plus 5, that is 13. We have 5 plus 8 plus 39, so that together gives you, this is 39 plus 8, it is 47 plus 5 52. This is the value of the determinant. Therefore A inverse is adjoint of A divided by determinant of A. Divide this matrix by the determinant value, which is 52. 1 by 52 into this matrix gives you A inverse. Now let's see application of matrices. Matrices are used to solve system of linear equations. Now I'll consider here a system of n equations in n unknowns. N linear equations in n unknowns, which is given by a11 x1 plus so on up to b1. So now I can transfer the same set of equations into matrix equation form by writing A as the coefficient matrix, coefficients of the variables x1, x2, x3 equation wise. First equation a11, a12, so on up to a1n, then a21, a22, so on up to a2n, then finally an1, an2, so on up to ann. Coefficient matrix. You have to write the coefficients of each equation one by one, row wise. Then the matrix B is matrix of constants here, b1, b2, so on up to bn. Then x is the matrix of variables here, x1, x2, so on up to xn. Now the same set of equations transferred into matrix equation as Ax is equal to b. So when you have a non-homogeneous system of linear equation, the system is consistent if determinant of A not equal to 0, and it has unique solution, and the unique solution is obtained by matrix method, which is given by x equal to A inverse B. If determinant of A equal to 0 system, then you have to find out adjoint of A into B. If adjoint of A into B not equal to 0, the system is inconsistent, there does not exist any solution. If adjoint of A into B equal to 0, the system is consistent, and in this case it has infinite solutions. Let's solve some problems. Take up the first one. Solve system of linear equation. Equations are given here. First you have to construct the matrix A, which is matrix of coefficients. Coefficients of first equation 1 minus 1 1, then 2 1 minus 3 in the form of x y z, then 1 1, then matrix B equal to matrix of constants 4 0 2, the values on the right hand side here. Then matrix of variables x y z. So first find out determinant of A, that is 1 into first row first column, 1 plus minus of minus plus 1, signs are plus minus plus. Then delete first row second column, that is 2 plus 3 plus 1 in first row third column minus, this gives you 3 plus 1 4 plus 3 plus 2 5 plus 2 minus 1. This is equal to 10. Determinant is not equal to 0. So that when determinant is not equal to 0, the system Ax equal to B has a unique solution, and that unique solution is obtained using matrix method. So by matrix method, what we have is X is given by A inverse into B. So I have to find out A inverse, then I have to multiply it with the B. So how to find out A inverse? Equal to adjoint of A divided by determinant of A. This is the inverse of. So first, to find adjoint of the matrix A, we want cofactor matrix of A. Factor of given matrix A. I'll write the matrix A here. This is 1 minus 1, 1, then 2, 1, then given matrix. So I have to find out the cofactor matrix A. First, delete first row, first column. 1, 1 minus, then delete first row, second column. 2 minus 3, 1, 1. Then delete first row, here first second column done, first row column 2 1, then second row first column minus 1 1 1 1, then second row second column 1 1, then second row third column minus 1, then third row first column minus 1 1 minus 3 3, then have third row second column 1 1, then the third row third column 1 2, finally cofactor. These are minors. Now to get cofactors, sign plus plus minus plus plus. Evaluate this to get the cofactor matrix, that is equal to, right here, 1 plus 4, then 2 plus 3 5 with the minus sign, minus 5, then 2 minus 1 1, then minus minus 1 minus 2, then 1 minus 2, 1 and 2 with the minus minus 2, 3 minus 1 2, then minus 3, minus 5 minus plus 5, then 1 3, the cofactor matrix. Now adjoint of A is the transpose of cofactor matrix minus 5 1, that is 2 0 2 2 5 3. This is the adjoint. Now determinant of A already, that is 10. X equal to A inverse joint of determinant. Okay, so 1 by 10, let me keep it, 4 2 2, then minus 5 0 5, 1 minus 2 3 into B, matrix of constants. Here there's a 4 0 2, right here 0. So multiplication, first row first column. Let me keep 1 by 10 outside only. Now 4 4 is 16 plus 2 into 0 0 to 4, 16 plus 4 20, then minus 20 plus 0 plus 5 2 is 10, is minus 10 minus 20 plus 10, then 4 plus minus 2 into 0 anyways 3 2 is 6, 6 plus 4 which is 10. Therefore divide this now, 20 by 10 is 2 1. Therefore on the left hand side you have x, x is nothing but x y z, hence x equal to 2, y equal to z. This is how to solve system of equation using matrix method. One more problem, solve the system So first write the coefficient matrix 4, 2, 6, 3. Then matrix of constants variable xy minus constant 6 and 8. Now find determinant of A, that is 12 minus, which is 0. Now determinant of A is 0 means you have to find out adjoint of A into B, which is equal to, how to find adjoint of 2 by 2 matrix, interchange diagonal, change the sign of 2 into B, 6 into 8. Now multiply these two. 6 3s are 18 minus 16, 18 minus 2, then minus 36 plus 32 minus 4, so which is not equal to 0. Adjoint of A into B is not equal to 0. The system is inconsistent. It has no solution. Now third problem. So construct the coefficient matrix 2, 3, 4, 6. The matrix of variables x, y, and matrix of constant is 5, 10. Find out determinant of A, that is 6 to 12 minus 12, which is 0. If determinant of A is, how to find out adjoint of A into B. So adjoint of A is interchange the diagonal element and the change the sign of to matrix. Adjoint of A to B is 5 and 10. So that is equal to 30 minus 0 minus 20 plus 20, 0. If adjoint of A into B equal to, then system is consistent. Yes, it has infinitely many solutions. Finite. Now to get those infinitely, you can take any of the variable as a k, either x equal to k or y equal to k here. Let me take if you take y equal to k, then substitute the equation x equal here, x equal to 5 k divided by 5 minus by, where k belongs to set of all real. So when you give k equal to 0, then y equal to 0, x equal to 5 by 2. This is a solution. Similarly, when you give k equal to 1, x equal to 5 minus 3, 2 by 2, which is 1. Equal to 1, y equal to 1. Solution, you can try. 2 plus 3 is 5, 4 plus 6 10. Then x equal to 0, x equal to 5 by 2 and y equal to 0. 5 by 2 means 5, y equal to 5 by 2, by 2. So go on giving the values like k equal to 2, then x equal to 5 minus 6 minus 1 by 2, so on. Now let's see application of determinants. That Cramer's rule. Now here we use Cramer's rule to solve system of equations using the concept of determinant. Suppose if I have considered 3 equations in 3 variables x, y, z, what you have to do is first form delta. Delta is the determinant found by the coefficient of the given system of equations. First row, write the coefficient equation a11, a12, then a21, a22, a31, a32, a33. Then construct delta 1, delta 2, delta 3. Delta 1 is constructed by replacing first column of delta by the constants b1, b3. Rest all remain same. These values same. Delta 2 is obtained by replacing second column of delta by the constant b3. Delta 3 is obtained by replacing third column of delta by b3. Now about the consistency, if delta is not equal to 0, the value of this determinant is not equal to, that key unique solution exists, and that unique solution is by x equal to delta 1 by delta, y is delta 2 by delta, z is delta 3 by delta. If value of the determinant delta is 0 and at least one of delta 1, delta 2, delta 3 is non-zero, means at least one you have to get one value non-zero, then there exists no solution. System is inconsistent. If delta as well as all three delta 1, delta 2, delta 3 are equal to 0, then you have infinite solution. So this is about the Cramer's rule. Let us illustrate this by solving problem. Now here solve the given system using Cramer's. So first form delta by writing the coefficient of the given equations. 2, 3, 1, then 1, 2, x first, y next, z third, 3, 2. Now you have to evaluate this delta. Is 2 into 1 minus 4, 3, minus 3 into, delete first row, second column. This is minus 1, minus 6, 7, then plus 1 into, then 2 plus 3, it is 5. This gives you minus 6 plus 21 plus 5 plus 5 is 20. Value of determinant equal to 0. Hence you will have the unique solution. Now how to obtain the unique solution? Find delta 1. Replace this first column by the values of the P 491. 491, remaining columns as it is 1, 2. Now evaluate this determinant. 4 into 1 minus 4 is 3. Next minus 3 into, expanding along the first row. Then delete first row, second column, and minus 2, 7. Then plus 1 in first row, third column, 18 plus 1, 19. Get minus 12 plus 33 plus 19. So have 19 minus 12 is 7, 33 plus 7 is 40. Delta 2 is equal to, similarly, replace the second column of delta by 491, 49. Then 2, 1, 3 as it is, 1, 2 as it is. What we get is 2 into minus 9 minus 2, 11, minus 4 into, delete first row, second column, minus 6, minus 7, plus 1 into 1, 27, 26. So we will have minus 22 plus 28, 6. So 28 minus 2, minus 22 plus 2 is minus 20. Similarly, find out delta 3. Delta 3 is, replace the third column, first column as it is, second column 2, 2 as it is, third column is replaced by 491. So this gives, now evaluate this determinant. 2 into, delete first row, 1 minus, that is minus 3 in, plus, delete first row, second column, 1, 27 is minus, plus 4 into, delete first row, third column, 2 plus 3, which is 5. 38 plus 26 into 3, then 20. So this gives you 70 minus 40, 40 plus 20 it is. Now therefore x equal to delta 1 delta, y equal to delta 2 delta, z equal to delta. delta. So delta is 20, 40. So 40 by 20, 60 by 20. X equal to y equal to 1, z equal. These are the values of the variables x, y, z using the Cramer's rule. One more example. Solve. First find out the determinant delta. 1 minus 2 minus 4. So 4 ones are 4 minus 4. This is equal to 0. When delta is 0, then you have to find out delta 1. If all delta 1, delta 2 0, then it has infinitely many. If any one of delta 1, delta 2 is non-zero, then it is having no solution. So first replace first column by 5, 8, second column as it is. Now if you get this value non-zero, then no. 5 4 20 minus minus plus 8 2 16, which is 46, not equal to 0. So no need to find out delta 2 here. Okay, you can stop because one of delta 1 and delta 2 non-zero, hence no solution is inconsistent. The Cramer's rule method. One more problem, solve. Here delta equal to 2 minus 1 minus 6 3. Then evaluate this. 6 minus 6, which is equal to 0. Again in this case delta is 0. Therefore you have to find out delta 1. So replace first column by 6 minus 18, second column as it is. So 18 minus 18 is equal to 0. Delta 2 equal. Now you have to find out delta 2. Check delta 2 on 0 or 0. So first column as it is 2 minus 6. Replace second column by 6 minus 18. So that gives you minus 36 minus of plus 30. 0. Now you can see delta 1, delta 2, all values are equal to 0. System is consistent and it has infinitely many solutions. Now how to get those solutions? By taking any one of the variable as arbitrary value. You can take either x equal or y equal. So I'll take y equal to k, then x equal to 6 plus k by 2 here. This goes to the other side. 6 plus y k, so 6 plus k divided by 2, where k belongs to r. K is any real number. You give k equal to 0. So y equal to 0, x equal to 3 is a solution. You can check here. X equal to 3, 3 to the 6 is equal to 6. X equal to 3 minus 18. Then y equal to 1. K equal to 1 you. Then x equal to 7 by 2 and so on. So go on giving different values for k. Hence you will get k for the given. This is how we solve system of linear equations, the Cramer's rule. I hope you understood. Thank you for